Hello there, 2D folks. I'm hoping that the your supervising teacher there, your on-call teacher, would just pause the video here, give you a chance to copy the 3-minute review and give it a go when you're ready, which will be, maybe not 3 minutes, but 5 or 6 minutes. Have a chance to try the 3-minute review, and then we'll take it up very quickly. So pause the video now, please. Okay, here we go. We're going to take it up, and I realize that I might go too fast for you. I want to remind you there, folks, that this video will be on. There'll be a link to on the website that you can see it over again, and if you didn't get the notes, remember they'll be posted on Facebook or you can get from someone else. So hopefully you'll follow along. This is just a review of yesterday's stuff. We're solving each system by substitution, and the idea is, sometimes we're going to have to solve for one, so we get m equals some other expression. I just moved the 2n to the other side. It became a positive. And then once I get m equals some expression, then I can sub that whole expression into the other equation. And here it was, I subbed this rearranged equation into equation 1. And then I end up with an equation with one variable that has n. I remove the brackets by multiplying 10 plus 4n, collect those like terms. That's what CLT stands for, collect like terms. Then I subtracted 10 from both sides, and I got n equals 4. Remember, you're not done there. That's only the first step. Then you take that, you go back into one of the original equations. It doesn't matter which one, remember. This one is pretty nice because if I just substitute n equals -4 into that, I can put that into my calculator in one step and get an answer. Okay, and then question 2, a little bit of a pain. You see, none of the coefficients of the p's and q's here are 1, right? So wasn't as easy solving for and getting p or q alone like it has been the last couple of days. And we could still do it. So for instance, in number 2, I decided to go with number 2 because getting rid of this 2 and dividing by 2 is easier than getting rid of an 8 or a 3 or a 5. So I took that equation 2, then I moved the 5q to the other side, then I divided by 2, then I got that p equals expression, right? I got that expression there, and then that's the expression I'm going to substitute into the other one. I substituted that into 1, and then I got some decimals. It's not very nice, but it actually worked out okay, because then I removed the brackets, multiplied by 8, the decimals disappeared, collected like terms, 20q and -3q make 17q altogether, subtract 24 from both sides because now I'm looking to get q alone, and then I end up with that little equation, 17q equals -34, and everything worked out fine. Q equals -2. Then I know I'm supposed to substitute back into the other equation. I substituted back into this one. So I let q be -2. Turns out that p is also -2, and then there's the solution. A reminder, and we don't do this every time, but this is going to be a good thing to remember on the test, and I will ask you to do this once or maybe twice on a test as a formal check. What we'll do is we take our solution and we'll substitute into the other equation that we use. Like we used equation 2 here to get the value of p and q, so we'll substitute into 1 to see if it works out. So for equation 1, the left side was 8p minus 3q, the right side was -10, and then when I substitute in my potential solution, I get it to work out, and then there's a happy face. It's all good. Now, what today's stuff is basically a way to avoid having these decimals and stuff like that. Substitution actually doesn't work that nicely all the time, like in this last example. So I'll give you a chance to copy down the note there. Again, you can pause the video while the folks copy down the start of the note, and then I'll get into it. So pause the video. All right, now it says, from the 3-minute review, we noticed that substitution was a pain if neither variable had a coefficient of 1 or -1. This happened in part 1b, and that was this one right here. The idea of when there's no coefficient of 1 or -1, then it's hard to solve for that to use substitution, so we can find something to substitute into the other equation. So we use a different technique. The idea here is, let's find some way to get rid of one of the variables that isn't substitution. And what we'll do is we'll basically get the coefficients to line up even though they're not ones and -1s. Watch. So I'm going to write down equation, call this equation 1 and call this equation 2, and I'm going to write down equation 1. And then what I'm going to do is I'm going to multiply -4 by equation 2. Can you do that? Can you multiply by something? Yeah, absolutely. We did that all the time when we were solving equations, right? Multiply and divide, add and subtract things, the equations sort of stay the same. They, when we multiply or divide or add or subtract things on both sides of the equation, they stay the same. So I'm going to multiply by -4. Now, where the heck did I get -4? Well, just be patient with me for a second. I'll show you. So -4 times 2p is -8p. -4 times -5q is +20q. And -4 times 6 is -24. And then what I'm going to do is I'm going to add. I'm going to add down this way. Watch. When I add, 8p and -8p becomes 0. And that's gone. The p's are gone. And that's what we want, right? When I add the q parts, -3q and +20q make 17q. -10 and -24 make -34. And now notice I've got an easier equation that involves only q, and I can solve for that. So why did I multiply by -4? I hope some of you have already guessed. It's basically I multiplied by -4 so that when I add it down, that the p's would be gone. So I kind of have to choose something that to multiply one of the equations, so when I add, one of the variables disappears. Okay? And that's this idea. This disappearing is we're eliminating one of the variables, and that's the whole plan, is to eliminate one of the variables, in this case p. Now notice we still got work to do, right? I still have to divide both sides by 17, and I get q equals -2, and I'd substitute back, and then the rest of the rest is the same as substitution. Okay, and this is the idea. And then we got a couple of examples to practice this elimination stuff. So again, you can pause the video, give you a second to copy the question. Okay. So notice both of these are those cases where there's no ones, so it's hard to use substitution. I can't solve for one of the variables and substitute into the other equation. So I'm going to use what we call elimination. Now, does it matter which equation we multiply? And in fact, in the next example, we'll see that we can multiply both equations. But anytime we see that one of the coefficients is a multiple of the other one, well, hopefully you recognize if I just multiplied this by 3, I'd end up with a 6 there, and then when I added, the y's will be gone, right? So what I'm going to do is I'm going to go 3 times equation 1, and I got to multiply each of these by 3. And then I'm going to write down equation 2. Write down equation 2, I get 10x. Oh, no, write down equation 2. What was I doing? Error. Just write down equation 2. And now notice, when I add down, the y's will be gone. They get eliminated, and that's the whole reason that we call it elimination. The y's are gone. And then 6 and 50, watch your integers there, folks. Divide by 14 now. Divide by 14 is the step. X equals 4. And then, of course, now that we get the first solution, we got to decide which to substitute back into, and it really doesn't matter. Sub back into, both of them are equally difficult, but I'm going to take out the x and put in the 4, and then I've got to solve for y now. Subtract 12 from both sides. That's the step. Negative 10, and y equals negative 5. And then, of course, a little statement. Therefore, oh, homework already? Not yet. We got one more to do. The solution is x equals 4, y equals negative 5. Or remember, if you prefer just writing the point, and we just put them in alphabetical order usually, x and y, like that. That's the solution. B. Now, see, B isn't as easy because, you know, if I multiply this by some, they won't line up nicely. I just had to multiply this equation 1 by 3 and it all worked out, but it's not that easy. So what am I going to have to do? I'm going to have to multiply both of these equations. So if I call this equation 1 and this equation 2, I can multiply both equations. And am I allowed to do that? Absolutely. And in fact, sometimes I have to. So I'm going to go, well, what will work? I need somehow to get the coefficients to line up. Well, what could I multiply these, for instance, to get rid of the m's? I'm going to go 4 times the first one. Say, well, where did you get that from? Well, hang on. I'll get to it. 16n equals 100. You get a little bit worried when the numbers start getting big, but this should be okay. And then I'm going to multiply by negative 3 times the second one, and then I get 12 and negative 12. Multiply by negative 3 and negative 18, negative 66, and then add down. Then the m's are gone. See, so we just got to find something to multiply both equations so that when I add, one of the variables are gone. In this case, m's were gone. Just a note as we're finishing this one off here, folks, this is 34. Divide by negative 34. Sometimes our book, like our book for this one, would multiply the first one by 4 and the second one by 3, and then instead of adding, they subtract, and which is fine. That's fine. But I always goof it up myself. So instead of subtracting, I don't subtract. I'll always multiply by a negative and then add, so I don't goof up my integers. And I do goof up my integers sometimes. So that's up to you. You can look in the textbook and see how they would do subtracting instead of adding, but you'll always see me add. You'll never see me subtract. I like multiplying by a negative and then adding. All right, well, we've got n equals 1. We substitute into one of the first ones. And it doesn't matter. I'm going to substitute into 2 here just so I can avoid that negative, I guess. Add 6 to both sides. 4m equals 28, and then m equals 7. And then a closing statement. Therefore, the solution is m equals 7, n equals negative 1. And again, remember, we can always do a formal check if we'd like, just like we did in the 3-minute review. A left side, right side check in one of the, well, usually it's the other one. See, we used 2 to find the value for m, so we do a formal check in 1, left side, right side for 1 to see if it checks. And some of you might be thinking, well, Mr. Estall, why did you eliminate the m's? Why did you decide that? Was my instinct to multiply this first one by 3 and this second one by 2, and then I could get rid of the n's? And absolutely, you can do that. Here's that very solution. So notice that when I multiply 1 by, and it looks like I might have made an error here somewhere, but let's see. Yes, this one should be, there should be a plus there. But then when I add, the n's are gone, and everything works out the same. And a smiley face. So it doesn't matter which variable that you decide to eliminate. Okay, there it is. Elimination, which works better if no coefficients are 1. Substitution is for when the coefficients are 1, and it's easy to use substitution. When it's not like that, then we use this new one, elimination. There's your homework, folks. You got the rest of the period to work on it, help each other, and hopefully whoever's supervising might be a math person and could help you as well. All right, that's it.